Okay, number one is asking us for the area of each regular polygon. If this is a regular triangle, we were first going to have to figure out what the height is. So we're going to have to draw an altitude, and that will create a right angle here. And we need to figure out what one of the interior angles of the triangle is. So if it's a regular triangle, it's an equilateral triangle, so one of the interior angles is 60 degrees. And all of this is just going to give us the height of the triangle. So this is off to the side what we've created. We're looking for x, the height. This is 60 degrees. And this is going to end up being only 4 because it's going to be half of the 8. So it's a 30, 60, 90 triangle, because if one angle is 60, then it becomes a 30, 60, 90. Side opposite the 30 is t. Side opposite the 60 is t square root of 3. So right here we already have t solved for us. T is 4. So everywhere we see a t, we can erase it and replace it with 4. So the height of this triangle is 4 square root of 3. The area for a triangle is 1/2 the base times the height, where the base is perpendicular to the height. So the area is 1/2 of 8 times the height, which we just found, 4 square root of 3. So we have 1/2 of 8 times 4 square root of 3, which is a total of 27.7 meters squared. Okay, number 3, this is a regular polygon. It's a 1, 2, 3, 4, 5, 6 hexagon. So first we need to figure out the angle measure of this entire angle. So all of the angle measures of a hexagon would be 180 times n minus 360. So 180 times 6 minus 360 gives us 720. And we would take that 720 and divide by 6 to figure out what each angle measure is, which we would get 120 for this angle measure. Now if we draw right down the middle of the angle, we are going to get the angle measure of 60 degrees here. So we're looking for the apothem using our 60-degree angle. So this is the figure that we have. A right angle, 60 degrees here, and they gave us the 6. Okay, opposite our 60 degrees is called t square root of 3, and that's what we're looking for. That's our apothem. And opposite the 90 is 2t. So if 6 is 2t, then t is 3. So x is 3 square root of 3. So that gives us our apothem. And this side length right here is opposite the 30, so that's just called t, which we already said t was 3. So this is 3, which means this is also 3, which means the side length is a total of 6. So the area is 1/2 the apothem, which is 3 square root of 3, times the perimeter of the polygon. The perimeter is adding up all the sides, or 6 sixes. 6 times plus 6 plus 6 plus 6 plus 6 plus 6, which is a total of 36. So the area is 1/2 of 3 square root of 3 times 36, which gives us a total of 93.5 square feet. Number 5, we want to find the area of the composite figure, so we have to figure out what shapes this is made up of. Well, if we draw a line straight down here, we see that we have a rectangle plus a triangle. So our job is going to be to find the area of the rectangle and add it to the area of the triangle. So starting with the rectangle, it's length times width. So 5 times 12, which gives me 60. That's the area of the rectangle. The area of the triangle is 1/2 base times height, where my height is perpendicular to my base. And if you notice, the whole thing is 20. So if we went all the way down, it would be 20. So the whole thing is going to be 20 minus 5, because we don't have this 5, which is a part of the 20. So the height here is 15. The base is perpendicular to the height, which is a total of 12. So our area is going to be 1/2 our base, which is 12, times our height, which is 15. So 1/2 of 12 times 15 is going to be 90. So now, to find the total area of the composite figure, we're going to add 60 to 90. So the area of this total figure is 150 meters squared. All right, the last one we'll do together is number 7. First, I'm going to draw a segment here just to show you that this is a semicircle. And if we draw a center point in here, we have a total diameter of 8. So the radius would be 4. Okay, so if we're finding the area of the largest shape, it would be a square. So once we find the area of the whole square, we're going to subtract the semicircle, because that's not included. And a semicircle is half the area of a whole circle. So starting with this area of a square, it's take one of the sides and square it. So 8 times 8, so 64. That gives us the area of the whole square. We don't want to include the area of the semicircle. So we are going to subtract the area of 1/2 pi r squared. And our radius, we said, was 4. So 1/2 our pi r squared, or our radius squared, is going to be 1/2 of 16. So it's going to be 8 pi, which is equivalent to 25.13. So this is 25.13. So we're going to take our 64 and subtract the 25.13 to get our total area. Which is a total area of 38.9 if we're doing to the nearest tenths place. And that's inches squared.